Your retriever just pulled 50 candidate passages for a question, and somewhere in that pile sits the perfect answer, stuck down at rank 30, buried under weaker matches. The trouble is your language model will only ever read the top few, so that perfect passage never makes it into the prompt. Fast retrieval is quick precisely because it is a little crude. Reranking is the second pass that fixes the order, and it is often the single highest leverage upgrade you can bolt onto a mediocre RAG pipeline. Let us break it down. So how does this funnel actually work? Follow it one stage at a time. The funnel opens wide. A fast first-stage retriever, a biencoder or BM25, sweeps the whole corpus and pulls a broad candidate set, say the top 50. It is built for speed over millions of documents, so the set is good but noisy, and the ordering inside it is only roughly right. Speed there is non-negotiable, since you are ranking against the entire index on every query. Now the funnel narrows sharply. A reranker, almost always a cross-encoder, takes just those 50 candidates and feeds the query and each candidate through the model together. Attention gets to compare the two texts word by word, which is far richer than matching two independent embeddings. Out of that joint reading comes a precise relevance score for every query candidate pair. Because the model actually reads both sides at once, this score is far more trustworthy than the crude first-stage ordering, and it surfaces the truly best passages that were buried before. Dedicated reranker models like Cohere Rerank or the BG Reranker make this scoring a clean drop-in call. Finally, you sort by those new scores and keep only the top few, maybe 3 or 5, to hand to the LLM. Since the model only ever sees this final handful, getting them right is what directly translates into a better, less hallucinated answer. So why add a whole second stage instead of just trusting the first ranking? Here it is side by side. Trusting that first ranking means shipping whatever the fast retriever ordered straight to the model. That ordering is quick, but it is crude. It compares independent embeddings or counts keywords, so the genuinely best passage often sits below weaker ones and never reaches the prompt at all. Reranking adds a precise second pass over only the top candidates. A slower, more accurate model rereads that shortlist and reorders it by true relevance, so the best passages rise to the top where the LLM will actually read them. You pay a little latency to fix the ordering that matters most. Strip it back, and 3 ideas define reranking. It reorders with an accurate model. A cross-encoder reads the query and each candidate together and scores their relevance directly, which is far more precise than comparing two independent embeddings the way first-stage retrieval does. It stays efficient by scope. The expensive cross-encoder never touches the whole corpus, only the handful of candidates that fast retrieval already shortlisted, so you get its accuracy for a small, bounded cost per query. It is a big precision boost. Because the LLM only ever sees the final few chunks, sharpening which ones make the cut directly improves the answer, which is why reranking is often the highest leverage fix for a weak pipeline. Alright, let us lock in what matters. Reranking is a second pass that takes the top results from fast first-stage retrieval and reorders them with a slower, more accurate model. That reranker is usually a cross-encoder, which reads the query and each candidate together and scores relevance far more precisely than independent embeddings can. The funnel is efficient because the costly model runs on only a handful of candidates, yet it sharply boosts precision at the very top of the list. Since the LLM only sees the final few chunks, reranking is often the single highest leverage upgrade for a mediocre RAG pipeline, with dedicated models like Cohere Rerank making it a drop-in step. If you enjoy retrieval explained this plainly, there is a whole lot more of it over at standarity.com. See you there.